Welcome to The Explainer. Today, we're tackling one of the most deceptively complex engineering challenges that's probably sitting right in our own backyards, and that is water drainage. If you've ever battled foundation moisture or those annoying grading issues, you know the golden rule. Water always wins if you don't use the right tools. So, let's just jump right in and demystify exactly how to manage it.
Why on earth is my basement wet, and where does all that rainwater actually go? It's a super relatable and, let's be honest, incredibly frustrating question. Well, today we are solving that mystery. We're going to break down the specific, purpose-built systems that are designed to fight back against things like hydrostatic pressure and surface runoff.
Okay, let's dive right into our roadmap for today. We'll start with the water management challenge, then go inside the French drain, followed by understanding storm drains. After that, we'll do a head-to-head looking at the key differences, and finally, choosing the right system.
Let's kick things off with part 1, the water management challenge.
We so often hear French drains and storm drains thrown around in the exact same conversation, right? But the reality is, we're actually looking at two entirely distinct systems that just happen to work side by side. One of them is all about micro-level property control, basically defending your specific foundation. The other? Well, that one's all about public runoff. It's managing massive volumes of water across entire streets and neighborhoods.
Moving on to part 2, inside the French drain.
So what exactly is a French drain? By definition, it's a localized drainage system installed below ground that collects and redirects groundwater or surface water away from an area. And honestly, that word localized is absolutely key here. We're talking about a highly targeted solution. It's engineered specifically to defend vulnerabilities. Think of things like a leaky basement wall or maybe a really low grading point in your yard where water just naturally loves to pool up.
The anatomy of a French drain is actually brilliantly simple, but it is incredibly effective. It relies on 3 specific components that work in total harmony. You've got a trench, highly permeable gravel, and a perforated pipe. Here's how it works. As water slowly percolates through the soil, it naturally seeks the path of least resistance. So it hits that gravel, drops down into the trench, enters the little holes in the perforated pipe, and safely flows away from your house.
And this brings us to a really critical engineering concept, reducing hydrostatic pressure. If you're not familiar, hydrostatic pressure is just the intense weight and force of saturated soil pressing against your foundation walls. Remember, water is literally incredibly heavy. We're talking about 62.4 pounds per cubic foot. That kind of pressure can easily breach solid concrete over time. So the French drain steps in as an underground interceptor. By collecting all that subsurface water, it artificially lowers the water table right near your home. This relieves that immense crushing pressure way before it ever gets a chance to enter your basement.
All right, let's shift gears to part 3, understanding storm drains.
Now we need to contrast that localized, slow seepage with a storm drain. A storm drain is a much broader piece of infrastructure, meant to capture and convey stormwater runoff really efficiently from paved surfaces straight to an outfall. So we are no longer dealing with a slow, hidden soak underground. Not at all. Now we're talking about managing above-ground, high-volume, extremely rapid rainwater.
To handle that kind of massive volume, you need some serious municipal hardware. We're talking about things like inlets or curb grates, massive underground concrete pipes, catch basins, and heavy-duty detention or retention features. Think about it. A single heavy downpour can literally drop thousands of gallons of water on a typical residential street in just a matter of minutes. This infrastructure is engineered specifically to swallow that rapid surface flow whole and move it out to a public watercourse.
Which brings us to part 4, head-to-head, key differences.
Now, what's really interesting about this is the stark contrast in the battlegrounds here. French drains fight an unseen enemy, that slow groundwater seepage moving laterally through the soil. Storm drains, on the flip side, battle the highly visible stuff. They handle the rush of rainfall-driven runoff that's just cascading over impermeable surfaces like asphalt and concrete.
And this brilliantly illustrates how, because the volume and the source of the water are so completely different, their ultimate destinations have to be totally different too. French drains utilize localized discharge points. They're dumping water into a sump pump, maybe a dry well, or just a daylight outlet right there on the edge of your property. Storm drains, however, connect right into massive municipal networks. That water is traveling miles and miles to reach major watercourses or even public treatment systems.
Okay, moving to our final section, part 5, choosing the right system.
Ultimately, it all comes down to correctly diagnosing your specific headache. If you're waking up to a wet basement, a constantly damp crawl space, or just a persistently soggy patch of soil in your lawn, your hero is without a doubt the French drain. But if you're dealing with sheets of rapid surface water washing down off a paved driveway and threatening to flood your garage during a massive downpour, well, then you definitely need a storm drain strategy.
Now, I do have to warn you, implementation is where DIY projects can very quickly turn into incredibly expensive disasters. Practical considerations like proper siting and sizing are totally non-negotiable. For instance, a French drain needs a very precise trench depth and the exact right selection of gravel to work. Meanwhile, storm drains require carefully calculated inlet placement and pipe capacity. You absolutely must consult your local codes and talk to licensed professionals. Making an improper connection could illegally overload a municipal system, or worse, it could literally accelerate the erosion right around your own foundation.
So the crucial point to take away from all of this is that the right choice isn't about one system being universally better than the other. Not at all. It's really all about meticulously matching the right drainage method to the specific water source and the exact area you are trying to protect. Remember, these are entirely different tools built for entirely different flows of water. Which leaves us with one final, pretty important question. What drainage mysteries are currently hiding in your own backyard? Seriously, the next time a heavy storm hits, grab a raincoat, step outside, and just watch exactly how the water moves around your property. Ask yourself, are you fighting a rapid surface rush, or are you dealing with a slow, hidden underground soak? Figuring that out is your absolute first step to securing a permanently dry foundation. Keep observing out there, and I'll catch you on the next explainer.